In this video, the learner will use similar triangles to solve indirect measurement problems. Indirect measurement is a method using similar figures to find missing lengths. We have this diagram here representing how deep some water is, a certain distance out from the shoreline. We know already that at a distance of 10 meters out from the shore, the water is 2 meters deep. What we want to do is estimate what the depth of the water would be 70 meters from the shore. What we can do is actually use similar triangles to help us do that. So we have a smaller triangle here with 10 meters out and 2 meters deep. And we know the distance we want out from shore, and we want to find out how deep the water is. We know these two triangles are similar because we know we're looking at a horizontal and vertical distance, which creates congruent right angles for both of those triangles. And we know because both of these lengths, the depths of the water, are parallel, we then know we have this set of corresponding angles congruent as well. So we have angle-angle similarity to show those triangles are similar. Therefore, we can use proportions to solve for how deep that water is. So let's look at an example here. In this example, we're going to solve for the missing length in this triangle. We know here we have a triangle within a bigger triangle, and this angle here is shared by both triangles, which means it's one set of angles that are congruent. The right angles are another set of angles that are congruent, therefore these triangles are similar. What we can do is we can actually separate the triangles, and it makes it a little easier to see what pieces are proportional. So I've separated the two triangles here, and we're going to put the lengths on each one of those triangles. So I have 5 and 10 and x and 22. We're going to match up the corresponding pieces for the similar triangles to solve for the missing length. So our proportion is x over 5 equals 22 over 10. Cross multiply to get 10x equals 110. Divide by 10 to get x is equal to 11. I want you guys to try this one. Try separating the two triangles and finding that value of x. In this example, we have two triangles again. Notice that the tree and the building will both be vertical and the ground will be horizontal. We know the horizontal and vertical will always create right angles. And we have this shared angle in both triangles here. So let's say I know how tall this tree is, and I want to find out how tall the building is. It's not really feasible to walk up the side of a building with a tape measure. So we can use similar triangles to help us solve for how tall that building is. For example, if I am standing right here at this vertex of this triangle, I know that distance to the tree is 24 meters, and then the distance to the building is 56 meters. I can compare those two measures to the height of the tree and the height of the building. So to set up that proportion, we could use x over 56 and 21 over 24. We can cross multiply to get 24x equals 1176 and divide by 24 to get 49. So that building is 49 meters tall. In this example, we have Stephanie that's standing 2 feet from a lamppost. Her shadow is 3 feet long. If Stephanie is 5 feet tall, how tall is the lamppost? So we want to draw a picture for this first. So let's draw out our picture. So we have Stephanie standing here, and she is standing 2 feet away from the lamppost. Well, notice we can actually draw a line from the top of the lamppost down, touching the top of Stephanie's head, all the way down to the ground. We could actually form right triangles doing that. When we do that, we've created two similar right triangles. And so we can set up proportions with the distances that we know. We know Stephanie is 5 feet tall. She's standing 2 feet away from the lamppost, and we know her shadow is 3 feet long. I want you guys to set up the proportion for this and solve for how tall the lamppost is. I want you to draw the picture and solve the proportion for example 5 and example 6.